model, a separate model in RH table. One is RH table, okay, first column number of sign changes we have to check. Second model, only first element 0 we will assume as epsilon. Third model, marginal k value and frequency of sustained oscillations, where we will get a complete row of zeros, So you can also see the same problem, I think. No, this is a different problem. S power 3 plus 2s square plus 4s plus k. This is the characteristic equation given. Okay. And RH table is prepared. And if at all mentioned marginal k value, marginally stable. Okay, k value where the system is marginally stable. That k value is called marginal k. And frequency of oscillations. Okay, marginally stable means the meaning is there will be fluctuations in the response. Output means response. Okay, C of t is the output. You know, if a system is there, generally input is represented by small letter r of t, output is represented by C of t. And when we draw the output waveform, if there are fluctuations in the output waveform, this is called oscillations. In undamped system, we come across this oscillations. Okay, sustained oscillations means oscillations are constant. Sustained means oscillations keep, okay, maintaining. So the system keep maintaining oscillations, or constant oscillations occur, that is called sustained oscillations. Marginal k means, okay, k value for which system is marginally stable. Marginal k value means the k value for which system is marginally stable. If we see the back or some theoretical points for this, value of k where system becomes marginally stable, or marginal value of k. Value of k which makes any row in RH table row of zeros, that is called marginally value. Okay, to obtain the frequency of oscillation, solve the auxiliary equation, then take what is the k value. The magnitude of imaginary roots of the auxiliary equation, okay, obtained for marginal value of k, indicates the frequency of sustained oscillation. First of all, we have to find k value. Then for that k value, okay, we have to find the magnitude of imaginary roots. For that k value, we have to find magnitude of imaginary roots. Okay, that roots will give sustained oscillations, because roots means on imaginary axis. Okay, this is S plane I am telling, and real axis is x axis is real axis, y axis is imaginary axis. If you say there occur root on the y axis, if you say there are roots on the y axis, the general format is J5, J3 like that. Okay, J5, J3 like that. These are the roots. In general, J into some omega value. Okay, some constant value, J5 minus J5 like that. Okay, this is nothing but J omega. This is nothing but J omega. So omega value equal to 5. Omega value equal to 5. Omega is nothing but frequency. Omega is nothing but frequency. Hence the name frequency of oscillations. Okay, the roots on y-axis. These are the roots. Omega value 5, but J5 minus J5, these are the roots. Okay, these are the poles on imaginary axis. Hence we are calling them the magnitude of imaginary roots. 5 is the magnitude. Magnitude means value of the root. Okay, 5 is the magnitude. Magnitude of imaginary roots that will give frequency of sustained oscillations, because that value is nothing but omega. That magnitude is nothing but omega. Omega is nothing but frequency of oscillation. That is the meaning of these 4 points. Now we are given with a problem. Let us try to find k value. Okay, then we will go with the what is the magnitude of imaginary roots. Okay, I will take up the first column. For system to be marginally stable, okay, a complete row of 0 should occur. I will assume this is 0 row. Okay, complete row of zeros are there, 0 row. In that case, it is 8 minus k divided by 2 equal to 0. 8 minus k divided by 2 equal to 0. Here we will get 8 minus k equal to 0 and k value equal to 8. Okay, we are finding k value as per step number 3. We are finding k value which is called k marginal. This is called k marginal. Now, Point number 4, after finding k value, what we have to do? Point number 4, calculate the imaginary roots. How we will calculate? The previous row to 0 row is called auxiliary equation. Previous row to 0 row. Okay, previous row to 0 row is nothing but auxiliary equation. We will find the roots of auxiliary equation. Roots of auxiliary equation. So now this is 2 into s square plus k equal to 0. And now substitute the k value. Substitute the, we have to take the coefficients. 2 and k are the coefficients. 2 and k are the coefficients. This is s power 2 row. Okay, this is s power 2 row. So 2 we have to put as coefficient for s square, and alternate coefficient, alternate powers only will come. S power 2, s power 0, like that only it will come. If you are starting with s power 5, alternate powers, s power 3, s power 1, like that alternate powers will come. So first term is having s square, next term should have s power 0. And here the coefficients are taken from this row, s square row. We are having coefficients 2 and k. We are taking those coefficients, and this is our actual auxiliary equation. I am making this as equation number 2. Already we calculated k value, k margin, that is 8. So 2s square plus 8 equal to 0. And if you cancel with the common factor, any cancellation common factor, we can do that. So s square plus 4 equal to 0 is the actual equation. This is equation 2a. 2 and 2a one and the same, because just we are substituting k value only. 2 and 2a are one and the same. Now we will find roots of this 2a. Now we will find roots of the 2a. Then that is called imaginary axis, roots on imaginary axis. Okay, so roots on imaginary axis we will calculate from auxiliary equation. Now s square equal to minus 4. We are trying to find roots. We are trying to find roots from the previous equation. S square equal to minus 4. S value equal to plus or minus square root of minus 4. And that minus should, square root of minus 1 can be taken as j or I. J or I. Okay, that square root of minus 1. Remaining square root of 4 is there. And s value equal to plus or minus j2. So this is plus j2 minus j2. Plus j2 minus j2. These are the roots on imaginary axis. Okay. So what is the frequency of sustained oscillations? Here this is nothing but s equal to j omega. And from here we can tell omega value equal to 2. Omega value equal to 2. This is our frequency of sustained oscillations. This is the frequency of sustained oscillations. Okay, at omega equal to 2 radians per second. 2 radians per second, we are having sustained oscillations. So what we have done, I have come in a rotational fashion. You can see I have written everywhere. I will take this black color. This is our actual question. Okay, this is our actual question. And in step 1, we are taking RH table. Step 1, we are taking RH table. And after RH table, for the system to be stable, this is our step number 2. This is our step number 2. For our system to be stable, okay, we are finding k value. For the system to be stable, we are finding k value. This is our step number 2. Then we are considering auxiliary equation. Step number 3, we are considering auxiliary equation and finding the roots of auxiliary equation. Finding the roots of auxiliary equation. We need not differentiate. We need not do any further things, but they are asking only magnitude of the imaginary roots and the frequency of oscillation. Okay, magnitude of the, we are trying to find magnitude of imaginary roots. Okay, and then frequency of sustained oscillation. Frequency of sustained oscillation. This is our actual question. This is our actual question. So in step number 3, we are finding the roots on imaginary axis. Roots on imaginary axis. Okay. And then from that, we are calculating the value of omega. And that omega is called frequency of sustained oscillation. Omega is called frequency of sustained oscillation. Okay. And now we are using k value. We are using k value in step number 3. In step number 3 and equation 2. Step number 3 and equation 2. We are following point 3 followed by point 4. Point 3 says first to find the k value. That k value is called k margin. Okay. Point 4 says use that k value to find the frequency of sustained oscillation. We have done that in step number 3. We are using k value in equation 2. Okay, then from there we are calculating the imaginary roots. From there we are finding the frequency value, that is called frequency of sustained oscillations. This is the new concept, finding k value and frequency of sustained oscillations. Such problems are very important, may be asked frequently.